All right. Thanks for coming to our session. Hope you guys all had a good lunch. All right, so you have 45 minutes to digest it now, quietly. I hope we will be able to provide a pleasant backdrop. So I'm really excited to be here today. I'm especially excited to be here, more so than usual, when I get the chance to talk to a room full of people, because I get to share the stage with Whaley. And so this is very exciting for me because, as an engineer, as a developer, I get a lot of satisfaction out of solving problems, coming up with hopefully clever solutions. I enjoy the intellectual challenge. But ultimately, all that really matters to me is the product and whether people actually use the product that I'm building or that I'm part of building. And I'm quite happy to say that Ben and Anki actually are users, day-to-day users, of the product that I have been involved in building for the last 4.5 years. So the last time we met, we just chatted and we basically talked about challenges that we're facing in building, these systems. And it turned out that in terms of approaches and general principles that we apply, there's a good amount of overlap, and we thought, hey, maybe it's a good idea if we just we put on a show, and we just kind of throw it back and forth. We talk a little bit about how we approach building resilient, always-on, scalable systems, and on AWS. So it's a perfect venue for this. And we probably, hopefully, will be able to have you walk away with a couple of ideas, best practices, based on our experience. So here's what we're going to talk about, very high-level agenda. We're going to talk a little bit more about who we are, what our companies do, so you know who you're dealing with. But then the meat of the talk is really going to be about approaches, principles that we have put in place in the systems that we are working on and have been working on. And ultimately, now some of these systems have been running for quite a long time, what we learned along the way. So I'm Christian. I started a company called Sumo Logic in 2010. At Sumo Logic, we're doing cloud-based machine data analytics. So we help our customers keeping their applications running smoothly and securely, which is important. And we also provide them a lot of information that they can use to troubleshoot issues if something goes wrong. Before that, I was at ArcSight, where, again, I was dealing with machine data, with logs, in order to make it easier for enterprises to manage security. So it's fair to say that in the last 15 years, that's pretty much what I've been doing. I've been dealing with logs. And the one constant that has been kind of threading its way through that entire time has been scalability. Even going back, to the early 2000s, the systems that we built at ArcSight, the problem that we were always facing, the challenges that always came up were around, hey, this customer has more logs than we could anticipate. They want to do more analytics. It's always more. It's always about scalability. And some of those learnings we've applied to Sumo Logic. And now, here's a quick overview of what we're doing at Sumo. We are basically helping folks deal with machine data. So what is machine data? Machine data is data generated by machines. So now we're safely in tautology land. But it is true, it's not human-generated data. It is not data that is being entered into a database via a form-based application or something like that. It is the data that is being generated while applications and servers and infrastructures go about doing the business that they are set up to do. We can bring this data into our system. Our system is a service, so you don't have to install anything, you don't have to manage anything, you don't have to scale anything yourself. And we can provide analytics on top of that data. Search, visualization, prediction. As I said, customers like to use this type of system so they can get insight into what their applications are doing at runtime. That is very important. We also help customers, staying secure, and we help them in, dealing with all kinds of compliance and compliance regulations in order to satisfy those various audits requirement. Because log data, machine data is a very common sort of set of data that is being audited, that's being reviewed, so you know what's actually going on for forensic use cases, et cetera. So it's all about scalability. This is the best way that I found to visualize what scalability means to us at Sumo. If you are a developer, actually forgot to do the show of hands. So how many marketing people are here? Excellent, thank you, welcome. How many of you guys fall into the sort of general category of DevOps architect? Excellent, so we got the right audience here. Not, So, if you are a developer, this type of scale curve should scare the shit out of you. And this is just the last 2.5 years of what we had to deal with at Sumo. The blue bars show the amount of data that we're ingesting per day from our customers. We are basically up to about 20 terabytes a day today. And of course, the data gets stored for 30, 60, 90, 180 days, sometimes even longer. This is already 4 times more than just a year ago. And then if you look at the pink line, what we can see is the number of queries that people are running against that data that we are ingesting. That's where the real value comes from. And that one is almost starting to look like it's growing exponentially. We're running 1 million queries per day in this system against this ever-growing data set. So our back-of-the-napkin calculation is, in order to satisfy that 1 million queries a day, we basically have to look, on average, at roughly 10 trillion messages per day. Scan, figure out whether they actually satisfy the query predicates, et cetera, all of that. So that is non-trivial stuff. And I could probably tell you a very funny and probably also sometimes very sad story about pretty much every one of those months. Because this is a scale that is just sometimes unprecedented, for us anyways. So this is what it means. This is what we have to deal with today. And this is kind of the setup for talking about scalability. And now I'm going to hand it over to Ben, who is going to give us an idea as to how they are, who he is, et cetera, and how they are approaching things at Anki.
Thanks, Christian. Thanks for coming. Hope you're all enjoying the conference so far. So I'm Ben Whaley, and I'm a cloud architect. I guess that's what I do. I design systems to run at scale in the cloud, and I did it for a couple years at Apogee, which you may or may not be familiar with. It's an enterprise API proxy, essentially, that will handle API calls for you, built on the AWS platform, running in 4 regions, several thousand instances. And I had a really fun time doing that, and I got to start over again at Anki. And I want to talk for just a minute about Anki, just to sort of set the context for why I'm here on stage with Christian today, because he's going to fill you in on the story about what it means to have a relationship with, he's running a platform that is accepting data, and we build a product that sends data to his platform. And so I'm not trying to sell anything, but I do want to just sort of set the stage for what Anki is, to give you context for the rest of the talk. Anki Drive is a consumer robotics and AI company. Founded by 3 Carnegie Mellon PhD students, and the first product is a game, essentially, in the real world, where there's sort of a vinyl mat that you roll out, and they're cars, robotic cars that they drive around the mat, and you can control them with your phones. It's targeted at kids, maybe age 6 to 12. Adults like to play it too. So you can imagine that, and this is sort of an Internet of Things type of a product. This is, I'd say, the beginning of the curve towards Internet of Things, where we have millions of devices that are going to be adding more data into the cloud, and this presents a lot of challenges for us cloud architects. I'm really going to quickly summarize some of the services that we run at Anki on the AWS platform, so you have an idea of how we use AWS resources. The most important of which is probably our gameplay analytics system. We call it DAS, and the idea is that whenever a game of Anki Drive is played, we want to know usage info. We want to know how our customers are using the game, whether there's bugs in the game. We can learn a lot about the product and how people are using it in the real world, and this is brand new for toys, right? This is a new experience where a toy is connected to the internet, and we can see see usage in real time. So that stack is, I probably won't read off the list of resources there, but that's the stack for the analytics system. The next most important system that we built is a custom-built customer account system. Everybody probably has some sort of account system. You're pretty familiar with doing it. We wrote ours in Go because we had some custom requirements. We wanted to make it run fast and effectively. I feel that Go is a pretty good match for running services in the cloud. It's a nice way to build microservices as well. So we built an API for custom customer accounts in Go, and we run it in a typical kind of 3-tier architecture where there's a load balancer and some app servers and some persistent store behind that. We use Twilio for a custom customer support system. So, users have a problem with their product or they want to know how to buy Anki Drive. They call up this Twilio-based app that, a couple of developers spent a month building. And having APIs and all these services on the cloud was a pretty powerful way to do that. We also run computer vision simulation. So a lot of our product is around computer vision, which is sort of a whole field in and of itself, right? You can imagine there's these cars racing around a track. They have sensors in them. Those sensors are cameras, and the cameras are sensing their place in the world. They're trying to figure out where they live. And we're able to use large Amazon instances to run many millions of simulations very quickly. And so our developers spin those resources up when they need them, and then they stop them at night so that we can save money that way. And finally, our e-commerce site is built on top of Magento. It's probably the most popular e-commerce platform written in PHP, and we run that and deploy to it using OpsWorks, and that's all hosted on the Amazon cloud. So I wanted to give a rundown because all of these different applications log data into Sumo Logic, and we use Sumo Logic basically for analyzing that data. Like, are our services healthy? Can I send an alert if there's a problem with the service? The sort of data that ends up in Sumo Logic's system. So with that, I'll hand it back over to Christian, and he can kind of elaborate on what happens to those messages after they end up there.
Thanks, Ben. All right, so we had this graph or chart earlier, right? And it just kept on going up and to the right. And so internally we kind of joke sometimes that what we're really doing is we're kind of sort of chasing infinity. Just extrapolate where it's going to be next year. So in 2010 when we started Sumo, we knew what success was going to look like. It was going to look like this. So Longcat there is us. And in fact, it actually turned out that way. So, all these other guys, that's essentially, what came before us. So we knew it was going to be massive. So knowing that, what did we do? How did we initially set things up? So in hindsight, I can say we decided to focus on automated, multidimensional scalability. So there's something for you to tweet. Of course, we didn't have those cool words back then, but we had a couple of principles. We decided to make the system multi-tenant from the beginning. We picked a scalable substrate, AWS obviously. We automated everything from the start, and then we modularized the code, and we broke functionality into services. I'm going to just drill down in these individual things. So ultimately, what we're dealing with is a lot of unstructured and polystructured, time-stamped, mostly textual data. So in some ways, Sumo is actually a giant, database for unstructured time series in the cloud in a multi-tenant fashion. So why the heck, did we add the multi-tenancy on top of it? Not that it wasn't actually hard enough already. It is because we think that it's the only way that we could build such a system and actually make it cost-effective. Cost-effective for us, and then ultimately also cost-effective for our customers, which is not unimportant. When you're looking at logs and machine data, what you will find is that the load, both in terms of the amount of data coming in as well as the amount of sort of analytics that you want to do, varies quite heavily. So, if you build it out yourself on-prem, or if you go with sort of a single tenant kind of, cloud-washed architecture, what you'll end up with is a statically provisioned system, based to some level. But the evil truth is that this is a kind of system that you need to work really well, especially when something is already going wrong. what happens then is usually more logs get produced, more queries you want to run, because now you need to do analytics, now you need to do troubleshooting. And so if you have a statically provisioned system, it's exactly in those crucial moments that you will probably outrun the system. So the multi-tenancy comes into the picture because of this. This is a classic sort of chart that shows the fluctuations in load for one of our customers. And a lot of our customers' charts would look similar to this, except for the spikes happen at different times. There's almost 8x variance in there. So that's pretty brutal. So imagine you had to provision this. You'll pick some sort of upper bound, and then most of the time you're just flushing money down the toilet because you're not going to use the resources that are there. And then it still doesn't help you when the proverbial hits the fan. So by going with a multi-tenant system, it turns out that across all of our customer population, on average, the load is actually reasonably predictable. And so we can provision for that. We don't have to provision for the peak for every customer. It means we are actually being able to serve more customers with less resources, which means it is more cost effective. And that is something that, of course, reflects itself in the amount of money we charge our customers. And so they have a great system that actually they need to pay less for. So that's the point about the multi-tenancy. We also said, hey, we need to build this system on the shoulder of giants. And so it just so happened that one particular well-known giant came to talk in our backyard back in 2008. And obviously I'm talking about Werner Vogels. I actually went back and looked at the Stanford webpage that was announcing the talk. So this was 2008, about 1 million years ago. They had a great content management system back then, as you can see. It's very interactive, too. In fact, just for kicks, this was actually recorded. There is a recording on YouTube from this talk from 2008. And, we went there, and it really opened our eyes to the possibilities. And why is that? Well, because we are developers. We are not data center people. We don't know anything about racking and stacking. We don't know all that much about the details of doing network architecture. We are developers. So what Amazon provides, and that was really eye-opening back then, it's worth calling that out. What Amazon provides is a data center as an API. And so now as a developer, API is something that I understand very well. So we managed to build on top of that substrate, and it has worked out really well for us. In fact, we just had an additional success story there this year. We got to the point where we wanted to bring our system to other regions, and Europe, Australia, APAC, and guess what? We could do that, and we did not even have to go there. Because we could simply use the automation that we already have, point it at the Europe region or Dublin, point it at Sydney, and now we have systems, now we have presences in those regions that we can use to basically serve customers or service customers in those regions. Data governance is often an issue, and data cannot leave the country and so forth. I'm sure a lot of you are well aware of that. That was not trivial, but it was easy. And this is something that basically, again, kind of reaffirmed for myself, that we actually made the right call back then. Automate all the things. You've probably heard that so many times that you don't ever want to hear it again, because it seems like it's almost, it's an obvious best practice. This made sense to us because we are developers. We don't do anything. What we do is we write code to do stuff. That's our way of thinking about things. And now I can write code to do a whole lot of things in a data center that I could simply otherwise not do. And for us, it was very clear that automation is key to the whole thing. Of course, in the beginning, we poked around the AWS console, maybe for half a day. And then we realized, well, we could either go down to the casino, and hit the slots, all day, or we could write a program to do it for us. And that's what we ended up doing. So the automation is absolutely key. We basically operate the system from our own CLI. And we talked about that in a talk last year a little bit more, but it's worth pointing out. Finally, scaling in depth. As I mentioned, We ended up from the very beginning, and it was not necessarily uncontroversial, to break down the system into modules and to break it down into individual components, internal services. Microservices is a term that's being used for that these days. It's very clean. Every sort of functionality in the system is encapsulated essentially into its own executable. And so our system is written in Scala because Go wasn't invented yet, I think. So what we have is all of these services written in Scala that basically talk to each other through very well-defined protocols, messaging and RPC. The code doesn't know anything about its environment, so we use a lookup service and what we call a service registry. So when one of these components that kind of make up in their own the entire service is started, all we need to give it, and this is literally the only command line parameter, a pointer to where the service registry is, and it fully bootstraps itself from there. Why does this matter? Why does this sort of breaking down things really matter? Because you will not ever be right. Under scale, everything you know will be wrong. It does not matter how smart I think I am. The system has proven me wrong so many times, I can't even count anymore. But with this divide and conquer approach, what we found is that whenever something actually broke, we could go in and oftentimes in a very isolated fashion, just work on that part of the system, that component that needed work, that needed scaling. We did not necessarily have to touch the rest of the system. So we really managed, and we got lucky there, but I think that principle kind of is really important. We managed to not ever architect ourselves into sort of this monolithic corner. Shit will break on you. If you have to rewrite everything all the time, you just won't be able to scale that. All right, so, that's a couple of thoughts from me. And I'm now handing it back to Ben to elaborate on the basic principles and approaches that have been successful for him.
Yeah, so I have a full slide deck of around 60 slides that talks about some of the best practices that I've learned building Apache's platform and Anki's platform and working with lots of other startups around the Bay Area. I don't have time to go through that all today, obviously, so I've boiled down what I think are some of the key takeaways that stem from that other slide deck. And so I'm gonna hit those and talk through a few of these points. The first is around n+2 redundancy. So this is a, n+1 redundancy I think is a thing that people have been talking about for a long time, certainly since maybe the 90s. People were planning to have an extra redundant system in case something went wrong. But today, we have regions with 3 or 4 or 5 availability zones, and adding another box, adding n+2 or n+3 redundancy is no extra work for us, right? It's an extra line in a CloudFormation script. Maybe it's in a loop, and I don't have to do anything. So it's a no-brainer to always over-provision it if you can, because you never know when something is going to go wrong twice instead of once. So anytime I build a system, I try to plan for n+2 redundancy, because it makes the Amazon cloud makes it so simple to do so. The next point is made widely, I think, in the community around compute being ephemeral, but I'm not sure it's always taken literally enough or seriously enough. And so when you think about this event that happened recently, you're probably familiar with the reboot stuff that happened due to the bug in Zen. That was probably pretty painful for some of you. Maybe some other people were really well prepared for that. And if you truly treat compute as ephemeral, then that reboot event was no big deal for you, right? In my environment, I try to make sure that every system, not just my application servers, but my databases, my config management servers, any management host that I have, a Bastion host, all of it's ephemeral. And maybe that means it's really easy to spin up if it dies, or maybe it means it's going to replace itself on its own with an autoscale group. The point is that there's nothing on the instance. I don't keep any state on the instance that I really have to care about. So that's a principle that I try to adhere to pretty closely. I never let a long-lived instances live in my environment. The next bullet point you've seen a lot of times, Christian just mentioned it as well, infrastructure is code. Sometimes they say infrastructure as code. This is brand new in the cloud. Like, think about it. Today, you can write a JSON template and it describes your network with all of your subnets and all of the security in it. your instances, your databases, your load balances, your entire environment can be described in JSON and handed off to Amazon, and like a bunch of APIs just go and make that happen for you. And this is like a sysadmin's dream come true. If you're a person that can think abstractly and write code, and you understand systems and networking, this CloudFormation and some similar tools like Terraform from HashiCorp, these are really pretty exciting developments that are changing how developers and how sysadmins are working today. I like to think about less is more, and when I say that, I mean simplicity, I suppose. So I mentioned that we use Go for building our APIs. I like Go because it's so straightforward. If you go and look at a random repository written in Golang on GitHub and you understand how to read Go, you almost certainly can read that code. This is not so true of a PHP app, right? If you load up a random PHP repo and you try to like sort through some spaghetti code, chances are 50-50 that maybe you could sort it out in a couple of hours or not. But Go is very straightforward. I find it to be very simple. When you build a Go application, you compile it. It compiles down to a single binary, right? Because it's statically linked. And I can ship that binary off to any system on the same architecture without installing any other dependencies, and it will just run. And so this is a really good example of less is more, in my opinion. CoreOS, I think, is another example. Maybe you guys have heard of CoreOS. It's a minimal Linux distribution that simplifies running an operating system. And the reason why I like it is that it strips out all of the unnecessary cruft. You know, over the years, Linux is it's a general purpose system that applies in many different ways. And CoreOS is aiming, I think, to build highly scalable web or mobile scale operating system. So that's another example of less is more. And those two things combined, you know, and CoreOS and Go, I think, make for a very potent and powerful combination. Ubiquitous monitoring is sort of a term I use. You may have seen this Twitter hashtag, monitoring love. There's a whole conference around it, Monitorama, which they spend a lot of time thinking about monitoring. And this is so important as a sysadmin, as a network professional, to think about, well, what am I really going to care about when I'm running my applications in the cloud? So I like to monitor as much as I can throughout the stack, the networks, the systems themselves, the applications, and I even like to try to derive business value. And this is so easy thanks to APIs. APIs really enable this, right? Because you can, in real time, you can look at the traffic, you can learn how your customers are using your application, you can learn what services are more popular, and what you can respond in real time to, say, some event like you're a trending Twitter topic. You know that because you can watch these logs in real time. So logging is kind of one part of the story, and then you might have your own custom monitoring system. Maybe you're capturing a lot of metrics and shipping them off to Graphite, or maybe you're integrating with some third-party service like Datadog or Stackdriver. In any case, it's so critical for ops professionals as well as developers to sort of infuse monitoring into their systems. And finally, around statelessness, I think that probably most people in the room would say, yeah, I get that, that's a best practice. But it's still worth mentioning again that if you're holding state on the instance, then that instance is not ephemeral, right? It means that if that instance went down, the customers that were pinned to that box, they're going to have a bad time. They're going to have to go remake their session, or they're going to lose some data or something. So best to keep state in some persistent store where it belongs, like a cache or in a database somewhere. So those are, at a high level, some of the best practices around systems and infrastructure. So I'll let Christian continue this train of thought.
Right on. All right, so we talked about the principles and the approaches that we took, and now we're going to talk a little bit about what we learned along the way, right? So it is ultimately 2014 now, and at least for me, we started a company in 2010, and so we kind of live in that future that we sort of designed for ourselves, and we set it all up right, and of course it's going to be easy, right? Well, not necessarily. The reality is that under scale, reality still has its own mind, and that you have to deal with. And so we were kind of going back and forth a little bit about sort of where to take this talk in this section. And the section is called Obvious versus Hard. And I had this feeling that talking about divide and conquer, about service-oriented architectures, around microservices, all of that kind of stuff. It's like, all right, I've heard this 1,000 times. Is it not totally obvious to everybody already? And Ben felt that, based on the experience that he has working with a lot of different companies, is that many folks just don't necessarily know this yet. And so we decided to drill down into this microservices stuff a little bit in particular. So when you do this, when you have this principle of divide and conquer, now the factoring that you're doing is important. Right? And it's no different in some ways from this sort of approach perspective than, as developers, what we've learned over many years in say, object-oriented programming. It's all about highly cohesive components that are loosely coupled. That's how we're supposed to write our code. But now what we find ourselves in is a situation where the infrastructure itself is expressible as code. And it's kind of interesting to look at, how the same principles continue to apply. So here is our current architecture. 5 years, 8 years ago, I would have probably shown you something with boxes and arrows between it and called it a UML class diagram. But guess what? We kind of are on the next higher level. It doesn't really look that different, just a bunch of boxes with arrows between them. But now what's in each of these boxes is an entire service. It's an entire executable. So in our world, we actually today currently run, last time we counted them, 32 different services. They are composed of 170 plus modules. I challenge you to look at our Jenkins and figure out what the fuck is going on. Anyways, there is complexity hidden in these things. It is just another layer on top of it. The way that we work this is, don't even ask me about the number of dependencies. I tried to count them and I kind of missed it a couple of times and I gave up. But you can see it's not necessarily ultra clean. But that's the reality. The world is not always pretty. So, and of course, all of these, this is a logical diagram, all of these individual components, we instantiate. Each of these services gets instantiated, at least 3 times, sometimes 500 times. Each of these actually become their own separately scalable clusters. And it's all completely decoupled through the use of messaging and RPC. So what I realized is that it's just the same old thing all over again, just on a different level. When we talk about factoring, when we talk about how to break the system down, how to break down the problem, just like we did in the object-oriented world, which we still live in to some degree. It's about factoring and it's about refactoring. Probably, one of the most famous books about, building software, in the old world is called Refactoring, Martin Fowler. I'm pretty sure everybody has read it. Don't ever assume, that you actually know what's going to come in the future. Apply what you know today and then keep refactoring the code as you learn more tomorrow. So what we're doing here, the need that we've seen in this kind of approach that we're taking is that, we need to refactor. Just as much as we needed to refactor back when we built enterprise software. We're not building shrink wrap anymore. It's a much bigger scale right now. But principally, in principle, the system is still sort of reacting to the same outside forces, and the same things apply. And now the amazing thing, and this is why I actually like living, as one of the reasons why I like living in this new world so much more today, and sometimes I'm thinking about what's the next world that I'm going to be living in and how much better I will like that. I'll probably explode of joy. The key thing is control and visibility. We are not writing enterprise software that we then give to somebody who is supposed to deploy and scale and so forth and maintain it. We actually do all of that ourselves. So we have that control. Simplifies things a lot. And we also have the visibility, and this goes back to one of the things that Ben said, of course. We can monitor it. Metrics, logs, APM, instrumentation. We can create our own big data story just by running this thing, basically, which is a big data thing in itself. So I'm not sure where this is going to stop. But that is really important. We found that it's really important. Look at what's going on because you can see what's going on. Don't be afraid to refactor. Don't be afraid to refactor your infrastructure. It is just code. It's all automated. Okay, and now I'm going to hand it again back to Ben, who's going to add in the lead on top of that.
Yeah, so this is another list, and it's the things that I have to remind myself of, or like the things that I have to think about a lot as I continue to build new cloud platforms. And I think it mirrors a lot of what Christian was just saying, and that's kind of one of the things I liked about how this came together. And the reason for it is that these really are some of the best practices, right? These are the things that Werner was talking about in the keynote in the reInvent 2012. If you haven't seen that keynote, it's totally worth checking out. He makes a lot of really great points, and a lot of what I learned and have done since then is a direct result of that talk. So the first point is around being open to change. You know, if you sat in the keynote this morning, you saw 7 or something new services being launched. You heard maybe 100 or so startups dying. That was kind of the joke at lunch, right? Which, I don't know if I should go on the record with that, but I already did. It's like maybe I just spent 3 or 4 months building a solution to some problem, and they just released this tool that solves my problem for me. And on the one hand, I could look at that and I could be kind of bummed out, like, why did I just waste my time? But that's really that's not the cloud way, right? The way is to embrace these things. And in my opinion, with Amazon, you can like go all the way and drink the Kool-Aid and get all of the benefits from it, or you can fight against it and be open to moving to some other platform. I don't want to be too locked into Amazon, and I truly believe that is the wrong approach. I like to try to make sure that my infrastructure and my practices will change to embrace these new services. The KMS service that was announced today is, I think, a really good example of why I stick with using Amazon. Here's a new service that is going to solve this whole set of distributing secrets out, right? This is a really hard DevOps problem, distributing secrets to instances. And now I have KMS that will just do it for me. And I kind of love that. So that's one thing I have to remind myself, rather than getting frustrated about new stuff coming, which is, I think, a natural human inclination, try to embrace it. The next point is around thoughtful network design. I think a lot of developers look at the cloud as like, oh, I don't have to think about systems and networks anymore, like IP addresses and subnets. I don't have to worry about it, and that's really not true, right? If you're a systems person looking at the cloud, you like it because you still get your private network on Amazon using VPC, of course. And I have all of the same kinds of concepts. I have subnets, I have NAT, I have some instances that are publicly addressable and some that are not. I have network access control lists and security groups, which are like Uber firewalls is what they really are, right? In a typical data center, you have a firewall in a couple of places, but with a security group, it's like a per role or a per service or however you want to put it together. It's a firewall for each one of those. And so I think it's important to spend a lot of time up front thinking about how your network should be laid out. Like I've got a whole set of CloudFormation, and I even have a couple of blog posts on what is a best practice for building VPCs. It's going to be a little different depending on the environment and the application and even the company. But I think putting that thought in up front is important. Composable services, this goes right in hand with what Christian's been saying around microservices. I'll use I mentioned earlier, our custom account system written in Go. We split it into 2 pieces where one is an API for creating accounts, resetting passwords. We have to comply with COPPA, right? We're targeting children. COPPA is the Children's Online Privacy Act. And there's a bunch of silly rules around COPPA, like if the person says that they're under 13, you can't email them directly. You have to email their parents. And so we had to have like these different flows. Anyway, that's why we built this custom system. We also want to store some data for our customers. We want them to know, you can sign in on your mobile device and you can sign in on your friend's mobile device and you can have all of your gameplay history. You can see all of the awards you've gotten in the game, all the medals. These are all like Anki Drive specific things. But it made sense to us to put those 2 things in different systems. And then they communicate with each other over a RESTful API. And so in that way, we can advance the development of one of them, and as long as we maintain API compatibility, then it doesn't really matter what we do internally. So that has to do with this concept of loose coupling. So loose coupling in the past has been if you Google it, you'll find a lot of hits around, especially in the Java world, around, well, how should I structure my classes to make sure that there's minimal dependence and one class can mature without the other. But it equally applies, and if you kind of look at it from the highest level, it applies to infrastructure as well. And Werner Vogels definitely makes this point in that keynote that I mentioned. He talks about queues being like sort of the prototypical example where if I have two services and they talk directly to each other, I can't really mutate either one of them, right? If I break one side of that, then the whole system kind of comes down. On the other hand, if instead the sender puts a message in a queue and the receiver receives from that queue, I can move either side, and like the whole system is still stable. So this happened at Anki last Christmas. We're a retail product. We're very holiday focused as a gift for kids. And so Christmas Day is by far the biggest day for Anki, like by a very, very large margin, several orders of magnitude. And so on that day, there was no way my infrastructure was going to handle the kind of load that was going to be thrown at it. And so by putting a queue out front, we have our client devices being sort of the mobile devices that control the cars, send messages into this queue. This queue can just buffer up all day long. And we used SQS. Like I said, I like to sort of embrace the services so I don't have to manage them. So SQS just buffered something like 20 million messages, and we were able to drain that over a couple of days, and my infrastructure wasn't just sort of flattened by that traffic. So that's one example of loose coupling in infrastructure. Another good example would, I think, any kind of a proxy is an example of loose coupling. Like an ELB is a good example, right? Because you're decoupling the clients that are talking to your web service from the web servers themselves, so that I can add and remove servers, I can update code, I can do rolling updates, maybe using Amazon's new code deploy tool, which undid a lot of work that I've been doing for the past several months. So I think that thinking about when you're designing a new system, thinking about how you can loosely couple the pieces will save you a lot of heartburn. And this last point is a lesson learned the hard way around feature flags. And also this isn't anything novel. Probably some of you have heard this before, but imagine you're developing some new feature and you've been working on it for a few months. It's nice to like bake that code in so you can continue to do your continuous integration and deployment, but not turn it on until you're ready. And so a feature flag is a way for you to do that. Maybe it's an environment variable you set. Maybe it's a flag that you pass to the app when you start it. But the point is that you can turn features on and off at will. Maybe it's a per customer sort of a thing, like this customer paid for this feature and this customer didn't. I think that building feature flags into your software is something that you'll benefit from if you think about what features that would be useful for. So I'll hand it back to Christian with that stuff in mind.
All right, so we're basically hitting the end of the allotted time, so I'm just going to basically skip through this. Come and find me later so we can talk about it. But essentially, here we go. That is essentially everything we wanted to talk about. So the takeaway is, if you just want to take away 3 things. Number 1, divide and conquer is your friend. Look into components. Number 2, observe, measure, monitor, exploit the fact that you have this visibility into what you're building these days. And number 3, feel good about yourself. If you build something that will tomorrow be announced as a service from Amazon, you have clearly done the right thing. Thank you very much.